All right, welcome back. We are GAME 2014 in the fall 2021 semester at George Brown, and it's week 7, part 2 of our broadcast. The first part was all around singletons. We talked about that. We also showed the singletons inside of our C# code from last week from Lab 4B. And now we're going to move on. Again, just a reminder of where we're at. We're sitting at week 7. And one thing we haven't talked about is touch input, presses, and gestures. And we're going to be talking about that inside of your midterm test, actually. I'll explain how this all works. It's actually quite simple. And you may have also learned about touch input from other courses that you've done with Professor Pollock, one I've heard from this morning's class as well. So it's not something that's completely new to you. All right, so again, that is something we're going to be talking about right now, as well as the midterm exam details. So let's begin with the document that I want to talk about. All right, so let's look at the midterm exam document. So here's your midterm test for today. So again, it's due Sunday, October 24th. It may have been labeled Saturday for whatever reason. Finger tapping errors on my part. It's due Sunday along with your assignment 1, part 2. That's also due Sunday. But I mean, you've been working on that theoretically for a while, so it shouldn't be something that is new to you. But this particular assignment is due Sunday. It's for 10% of your final grade. And what you need to do is you're going to be working with a specific template that I've given you. Unfortunately, when I gave it to you, there was actually 2 folders. Please stick with the fall 2021 folder. They're the exact same as an example, but please work with the fall 2021 folder. And maybe what I'll do next, after this is I'll update the zip archive so it only has 1 folder in it too. All right, so that's the first thing. So let's take a look at the project and see what it is. So I'm going to open that up. Let's just close off the other project. This is our Lab 4B from last week. And let's open up the midterm template. And let's see what that looks like. All right, so midterm template, it's a zip archive. It's not a GitHub link, right? So this kind of changes every semester. One thing is that this is the project. It looks similar to what you've done in your Lab 4B, but it's actually different in many aspects. And we'll talk about what that is. So that's why I want you to use this project template, not another one, not Lab 4, not something else, this one. Okay, what I need you to look at, right? So let's not look at the safe area for a second. Let's see what this looks like. You can see that in the simulator, the project looks like it is in, that's in portrait orientation, and that's great. What I want to do is just launch it and see what it does. So let's just run it. So by default, it does this. It uses touch input where I can move my character around the screen by touching somewhere on the screen. It doesn't do anything on the y-axis, so it limits the character, the player, only to work across the x-axis. And notice it fires a series of random bullets, right? Random bullets at the enemies as I kind of drag my finger around the screen. Okay, that's what it does. The enemies kind of bounce from right to left and left back to right across the top portion of the screen. That's the enemy. And I can see there's several enemy prefabs that I've got here, a few of them. Notice that the enemy does have a collider, and when the bullets hit the enemy, that the bullet kind of disappears or resets. So there's 2 times that it can reset. One, if it misses the enemy and it goes off screen here, and the other time when it hits the enemy, and if it does any kind of collision, it also resets. So those are the 2 cases where the bullet resets, okay? There's also, notice that there's some spaces when it comes to bullet firing. So it's firing bullets. And then what happens is, sometimes you can see that there's spaces in between the firing, and it happens when, because we have a limited pool, so there's some issues with how I'm doing this, but it's okay. We've talked about dynamic allocation of bullets in Lab 4 and earlier, so we talked about that. So what's happening here is that it's just firing bullets from the player. Notice that the enemy is not firing bullets down. So there's no enemy firing that's happening. Okay, so that's the project. You've been tasked, all right, if you look at the document, let's look at the document here. You've been tasked for a couple things. To make the space shooter work primarily in landscape orientation. Okay, all right. And some people were really smart last semester when I had this same midterm, and they said, Tom, I mean, it's done, right? I mean, all I have to do is go back to my Unity project when I run it and just rotate it, right? I mean, all I have to do is just do this, and it does exactly what you're looking for, right? Wrong. That's not what I'm looking for. I'm not looking for you to rotate it by clicking this button. Okay, that's not the answer to your project dreams, right, for this semester. Okay, sure, it should look like this when you're done, right? With a couple of exceptions. One, the lives and score label probably should be across the top of the screen if you're going to use the lives and score label, even though I didn't mention this, right? Number one. And the other thing is that here in the scene, notice that I'm firing straight up. I should actually be firing to the right in the scene, just like I'm showing here in the game. So yes, this is kind of what it should look like, but no, it's not complete. You have work to do, all right? This is just kind of similar to what it's gonna look like at the end, but it's gonna primarily work in this mode and then not work in portrait by default, okay? So clicking the button, not good enough. Please don't think you're done, number one. All right, so let's go back to our details here and see what it says. So again, task 1, modify the scripts attached to the game objects in the main scene. You may also modify the transform component of game objects using the inspector. Those are the two things you can do, scripts or the transforms. The main scene must use the assets provided in the template, okay? The main scene must be set to landscape orientation. Right now, it's set to portrait, right? The main scene does not mean don't flip. That's not what it means. Actually, make it so that the screen is set up so that it's going to work on a landscape orientation, not portrait at all. Okay. The player's ship starts on the left-hand side of the screen in a fixed X position, similar to having a fixed Y position at the bottom of the screen. Again, going back to our project, right, you can see that here we're on a fixed Y position. We can't move up and down. We can only move left and right. What you're going to do is you're going to make it so that you can only move up and down like this. Okay, so a fixed X position, but a movable Y position where I can go from the top of the screen to the bottom of the screen. Okay, so that's kind of how it's going to look like. And let me continue. The player ship will move with touch input only. All right, so actually we have both touch input support and mouse keyboard support. Let me show you this piece here. So let me move this back the way it was. So inside of the player controller, let's take a look at that. The player controller, if you look at the top, and I've given you an example here of I didn't do it in your files, but this is an example of some internal documentation for your full name, student ID, your date modified, your file, description of what the file would do, more than this please, as well as a revision history, a short revision history of what you've added or changed, right? But if you go down, you can see that I've kind of created this private vector3 called touches ended. And I instantiate a new object of vector3 here, kind of create an empty vector3 or a vector3 that's zeroed out, 0, 0, 0. And then we use an update function, a standard update function here in your player controller class. And the standard update function, what it does is it has move, checkbounds, and fire. We've seen move and checkbounds before, right? We've done that very similarly in our lab. However, our move works a little differently. The move does two things. One thing is it has a direction. Movement has a direction. And for touch input is super easy with Unity now. Using the older system, that's why I'm using the older input system, you can see that I kind of loop over, I use a ranged for loop, or a for each loop here in C#, that's what it is, where I have a number of touches in touches, where the input manager itself that's built into our Unity, the standard one, has a touches property. And the touches property, basically, it detects any kind of touches you have on the actual screen itself, right? For mobile. Before, they had a bunch of extra stuff that you had to set up to make touches enabled. Now touches are always enabled. However, you can always disable them as well. So for every touch in touches, what I want to do is take that touch position, whatever the position is, which is a vector2. If you hover over, it says that touch position is actually a vector2 object. So it's on the screen itself, and it's in screen space. We want to convert that touch from screen space to world space, right? And we want to save that as a temporary variable, temporary object. So that's the vector3 in world space is what we get out. And then what I want to do is I'm saying here, the way I move is if my world touch, my touch that I just made on the world is to the right of my current position, then my direction is towards the right, right? It's a positive direction. If my touch is to the left of my current position, then my direction should be to the left. So I just indicate which direction I'm going in depending on the touch that I'm using. Okay, now you could simplify this and use a ternary operator, right? But we're not going to do that here. Then what we want to say is we want to store the world touch inside of touches ended. That's just a variable that is private that's inside of our class, a class variable, right? So a private member variable called touches ended. That's where that actual touch that you used is being stored in, okay? The last touch is really what that is. And I also support keyboard entry for testing. So if you want to test without your simulator, you want to test in a regular environment, you can do so. But however, what I want to do is I want to say that, okay, so how do I move? So now I know the direction, but what I want to say is if my touches ended, the X component of my touches ended, remember that this touches ended is X, Y, and Z, it's a vector3. If it's not equal to 0, if it's not the 0 position, the middle position, and mostly it's not going to be, then what I want is for my transform position to equal to a new vector2 object. I'm generating a new vector2 object, and I'm using this mathf_lerp function. Remember what lerp does? It's linear interpolation. It goes from one value to the other value with some kind of t value. So a value of x, meaning this is where I'm starting off, whatever the current x position is, and then I want to compare it with wherever I'm touching. There's a line that I can draw between one point and the other, and depending on where this is, I want to get 10% closer. Horizontal value is a value between 0 and 1, where 1 is exactly at the new position, exactly towards the touches ended, and 0.1 or 0 would be towards this one, towards the original position. So what I'm saying here is linear interpolate between x, where I am right now, where I want to go, to some distance between where I am and where I want to go. And this horizontal value, this horizontal t value, I'm actually storing here in our player behavior. So in player behavior, I have a player controller, and you can see that the horizontal t value is set to 0.1, and that what that means is it's closer to the original touch or the original position, right? And so I linearly interpolate from wherever I am to wherever I'm going 10% at a time until I get there. But I don't do anything with the y value. The y value stays constant because I'm not affecting my y. If you were going to use a lerping value to move your ship, instead of going left and right, which is what this does, you would have to modify this transform position, this new transform position, so it can move up and down. Right now, it only goes left and right. Okay? And what happens if this is only if and only if that the touches ended is not equal to 0. If it is equal to 0, if I haven't touched it, as an example, then what it's going to do is it's going to slow down by itself. It's going to slow down, and it's going to be a natural kind of a slowdown. It's going to clamp between the new velocity, whatever that new velocity is, and max speed. All right, so that's what this little if statement does, and that's all inside the move function. That's what allows me to move my player around the screen when I press play. So I press play, I touch somewhere, and it's going to try and get there. It's not instant. It's not like teleporting to that place. It's going to go to that place. So it moves to that place. And I can modify these values. Let's say, for example, I modify this value so it's really low, like 10% of that. And if I click over here, it's going to go there much slower. So you can see that it kind of goes there as fast as I want it to, right? There you go, okay? So it kind of slows down when I get there. So you can modify this value, or I can make it really, really quick if I want to as well. The smaller the value, right, then the slower it's going to get there, right? Which makes it way less playable. Okay, so that's why we keep it around 0.1, anywhere 0.01 to 0.1. Okay, is where it should probably be. And we could make a slider, but I didn't do that here for you guys. I'm just showing you how this works. So you can also change the maximum speed, how fast it does that, as well as the current horizontal speed. So you can modify these values here so you can have different gameplay effects over here. But that's what this does. That's what the move, this move stuff, how it works for the player. Okay. And going back to this, it says that the player ship will move with touch input. That's how touch input works. You go for every touch in input.touches, and you take that touch, convert it from screen space to world space. And once you've got that screen space to world space conversion, you have a vector 3. And from there, you know, you can actually do something with your object. Okay, next, the player ship will be rotated to face the right side of the screen. Right now, if I go back, the ship is kind of pointing upwards, right? You want it to point to the right. Okay, so the camera right now, right, is kind of situated so it's pointing up. We want the camera so it looks, the whole screen is kind of pointing to the right, right? That's what we want to do. We want this situation, right? So it kind of looks like this. But right now, our object is looking straight up. Okay, so how do you do that? Well, we can rotate the object. There's a couple ways to do that. We can rotate it across the z-axis. So let's say, for example, I want it to go 90 degrees, right? I can make it rotate any direction I want. Okay, remember that you have a transform that's a part of every game object. All right, so rotate the ship to face the right side of the screen. 5 points to do that, okay? And the player ship will only be able to move up and down. Okay, so that is what I talked about, movement. Modify the movement of the player ship. And the player ship's motion will be limited so that it cannot leave the borders of the screen. It kind of is like that right now, but it only works right to left. You need to modify that check bounds method that we just saw in the code. So here is our check bounds method. And the check bound methods check to see if my object is greater than the horizontal boundary or less than the horizontal boundary for the right bounds and left bounds. You need to kind of do the top bounds and bottom bounds, which is something that I don't have here. So you'd have to modify these scripts here so that it works up and down, not side to side, okay? And so that's from 1A to G is what I've covered here. H, the starred background assets will scroll in from the right side of the screen to the left side of the screen instead of the top to bottom. Okay, let's take a look at the starred background. What do I mean by that? It's this. I have a background asset here. And the background, if you actually watch it, I'm going to click on background. What it does is you have this starred background. The background itself is transparent, except for these areas that you see these weird stars, right? The star pattern. And what you're going to see is that the stars, there's two of them. There's two backgrounds. There's the top background. Think about this as a background sky. And the bottom background, this one here. And you can see that once the top of my background leaves the bottom of my screen, look, it then resets back to the top. And it does this synchronously with the other background. So what's going to happen is that you have this almost like an endless scrolling effect happening here with these two backgrounds. How does this happen? Well, um, we have a background controller, and the background controller is like super easy. Again, you can see an example of here in the video where I've got a background controller and I got a bit of some header to my file where I've put in like my name and student ID and all this kind of stuff and what this thing is as an example. And I have two functions that are in the update method. One of them is the move and the other one is check bounce. Very simple. And I have a private reset method that I'm using as well. So the way it works is I move and I literally just change the position of the object. I'm not using rigid bodies or any kind of physics here. I'm literally just moving the object, and I'm moving it according to the vertical speed that I've set, multiplied by delta time. And this just slows it down a little bit, so it scales it according to my system. And then what I'm doing is I check bounce. So I do move and then I check bounce. And the only bound that I'm checking is the bottom part of the screen. So I kind of go to the bottom part of the screen, and when I reach the bottom part, then I call the reset method, which resets my position to the top part of the screen, right? Whatever the top positive vertical boundary. And I've set these values, vertical boundary, positive and negative. I've set that inside of here, inside of our code. So vertical boundary for the first one is 10, and for the bottom one is also 10, but they've actually started at different positions. So I actually positioned them so that they're on top of each other. So one background is actually right next to the other one. So when it passes from the top to the bottom, it kind of circulates, and we can see that what it does is it is being reused. Watch. So it kind of falls, and as soon as one background leaves the other one, it resets back up to here, and it keeps doing that over and over again. Okay, so it looks like the background is infinite scroll. Okay, but we don't want this to happen for you. What we want is the background to scroll from right to left. Right to left. So right to left scrolling means that you need to change this background controller script so it starts from the right boundary and then leaves the screen to the left and comes and kind of is reused to the right. Okay, so it kind of cycles or recycles in from the right hand side of the screen. And that's what this says. It says the background will scroll from the right side of the screen to the left side of the screen instead of from the top to the bottom. Okay, so there's two different background assets. You have to make sure that they're aligned properly and move in the right direction. Next, the player's bullets. Right now they're firing up. They're going to fire to the right. Okay, so that's the next one. And we can see where that's happening in the bullet behavior script. So you can see that there is probably some kind of bullet controller, right? There's a bullet controller, and the bullet controller, what it does is it does a couple things. Right? It also implements the iApplyDamage interface, right? The iApplyDamage interface, if we go and see what that is, go to definition, you can see that all it is it, when you implement the iApplyDamage interface, you actually must create a method that returns an integer called applyDamage. ApplyDamage. So whenever I implement a method or a class of type iApplyDamage, then I must have a method called applyDamage that exists in my class. I create a contract, with the class that says when I implement an interface. I'm not doing multiple inheritance here like in C++. Rather, what I'm saying is I'm inheriting from monobehavior, but I'm also implementing the iApplyDamage interface. And in order for me to implement it, I need to create an applyDamage method. I must override this method with my own return type. Here, I'm returning damage. And what is damage? Damage is an integer that I can set. So every bullet then has its own damage, whatever that damage is. And I'm going to get that damage that's set up inside of my bullet itself. So if I go back to prefabs, and if I look at bullet, there's three bullets. There's bullet, fat bullet, and pulsing bullet. So bullet, you can see, is here. And we can see that the bullet itself has a couple things. It has a collider, and it also has a rigid body. but the rigid body isn't being used right now. We're making it so that it uses a trigger collider to collide with other objects. When we use a trigger collider, at least one of the objects that's being collided with must have a rigid body, okay? And we can see here that in my bullet controller, that the standard bullet uses a vertical speed of 4 and the vertical boundary of 5.1, as well as my damage is set to 0 right now. Okay, same thing with fat bullet and pulsing bullet. Okay, pulsing bullet, fat bullet, all those things are the exact same configuration. However, they all get set up properly in the factory. And let me show you where that is. So if you look at the factory itself, going back to this, the code, if I go back to Bullet Factory, let's go to that. So again, in scripts, you can see that there's a Bullet Factory. And the Bullet Factory, what it does is it gets references to regular bullet, fat bullet, and pulsing bullet. And by default, the reason why it is I get random bullets firing out is because my default bullet type when I create a bullet is a random type bullet. Okay. When I create my bullet, not only do I instantiate an object of type bullet, the one that I want, depending on which random one I choose from 0 to 3, right? Where 0 is, as an example, the first type, regular bullet, and 1 is fat bullet, and 3 or 2 is the pulsing bullet. So it makes a range that's exclusive. So it does not include the last range. So 0, 1, 2, and it gives me a random bullet. And what I'm saying is that the type of the random bullet is going to be whatever I set. So I say, take the bullet type. Let's go to that go-to definition. I have regular, fat, pulsing, and random. Those are the bullet types, right? And I generate a random bullet type. And in the switch case, I say, okay, depending on what the type is, if it's a regular one, fat one, or pulsing one, as an example, then I want to change the bullet controller's damage to 10, 20, or 30, depending on if it's a regular, fat, or pulsing bullet. And let me show you what that looks like. So if I did this, and if I ran it, and if I look at the prefabs that are generated, and by the way, the bullet manager has all the bullets, and if I choose one like fat bullet, you can see that that fat bullet clone has 20 damage, whereas pulsing bullet has 30 damage, right? Pulsing bullet has 30 damage. And my regular bullet, right, so which is just bullet, has 10 damage. Okay, that's what it should be, right here, 10 damage. And that's set up depending on the bullet type, whatever the bullet, whether it's regular, fat, or pulsing, okay? How does it do this? How does it generate a random bullet? Well, by default, the type is random, right? So and that's why I've set it up for this particular thing. However, you could set it up so that the player always fires a regular bullet or a fat bullet or a pulsing bullet, depending on what kind of bullet you want. Again, bullet factory idea. So that means the player controller, when I fire a bullet, and that's in the check or the fire bullet, when I get bullet, I tell it where to go, right? So say, hey, bullet manager, get me a bullet, right? And if I go to definition for get bullet says, I'm going to get a bullet from my pool. And the bullet pool itself, if you notice the bullet pool, the bullet manager, the bullet pool, it tells me the type of bullets, right, that I want to fire. It tells me the maximum bullets that I want to fire, and I get a reference to the bullet factory. One thing we talked about earlier in the first video was we're in our lab 4, I made the bullet manager and the bullet factory singletons. It's not the case here for your midterm exam. Okay, so your midterm exam, if you look, the bullet manager has 2 scripts, which is the bullet manager itself and the bullet factory. Those are the 2 scripts, okay, that we use. So then how come when I create a bullet, how come it's always random? Well, remember that we create a bullet based on when the bullet manager calls the bullet factory, because we know we have a bullet factory object here. And here I just use create bullet, all right, which calls a random bullet, right? So if I wanted my player to always shoot another type of bullet, let's say, for example, what type it would be, I could say that I want to use bullet type regular, right? That's the type that I want. And if I was to specify that in the create bullet call to the bullet factory, then if I go back up to here and I run the script again, it'll always be regular bullets from now on, right? That's how it should work. Regular bullets. Okay? So that's how it would work. I'm just going to do that. But normally what it does is just randomly puts off whatever random bullet that it creates. So if I do that again, and if I just took that away, it's going to just generate random bullets. There we go. All right, so that is the way that things are tied together, right? And that's kind of takes care of this idea of the player's bullet fire towards the right side of the screen and originate from the player's ship. Okay, so if you notice that, one more thing, if I look at the player doesn't have a spawn point for the bullet or a bullet spawn. The player, which is, I use player controller for this, when I use the bullet firing script, it comes right from the player object, like right on top of the player object. There's no offset, which would be the bullet spawn position. Okay, that's something to note. There's no offset whatsoever. And the bullet controller, which is here, what it does is it moves the bullet to the right. So notice it says a vector 3 with 0 across the, it moves the bullet up. 0 across the x-axis. We add vertical speed across the y-axis and 0 across the z-axis multiplied by delta time. So it only moves it up the screen. That's what it does. Your job is to make the bullet fire to the right of the screen, towards the right. Okay, so that's something different that you have to do. That is part I. Okay. Part J, the enemy game objects will be positioned at the right side of the screen. Okay, right now they're positioned at the top of the screen. So again, going back to this, you can see that the 3 enemy game objects, enemy 1, which is this one, okay, enemy, you can see that its position is on the y-axis is 4, but it's on the x-axis is 0, and you can see that it's differently positioned. They're also pointing down at you. They should be really facing towards you, right? And it says they'll be positioned towards the right of the screen, right? And the enemy game objects will move from the top to the bottom of the screen instead of moving from left and right. They will reverse direction when they hit the borders of the screen. So in other words, right now, the enemy object, right, it moves to the right and left, right? Take a look at them. So here's the enemy object number 1. Oops. This one. So you can see as it kind of hits the left part of the screen and then goes and moves to the right side of the screen and keeps doing that over and over again. And so does the next one. You can see it does the same thing. It kind of bounces from one side of the screen to the other. Okay? What we want you to do is make it so that it goes up and down, right? When you're in landscape orientation. Okay, so that's a different behavior. In order for you to look at what the behavior is for the enemies, take a look at the enemy controller. So the enemy controller, you can see that we move, and what it does is it says, okay, I want to just use my transform position, add in my horizontal speed, multiply by a direction scalar, okay, and times time.delta time for the x-axis. This is all the x-axis stuff, right? Y-axis and z-axis doesn't change. But where do I get my direction from? Well, I check if my object is towards my right boundary. If it's greater than the right boundary, then go back to the left. That's what this direction is going to be. If the direction is towards the left boundary, then start going towards the right. And you can see that inside of the enemy objects that there is a direction variable that we can see here in the inspector. So here, if you look, there's a direction variable. And if I was to run this thing again, you're going to see how that direction variable will change. So it hits the right, it goes to negative, and then goes to positive, and goes to negative. And it keeps doing that left and right. Okay? So what I want you to do is you're going to move up and down, and the direction is going to be changed according to a new set of boundaries the top boundary and the bottom boundary, not the left boundary and the right boundary. Okay. So again, this is all, I think, pretty straightforward so far. All right. So there's nothing that's out there. Again, professors always think this stuff is pretty straightforward, but I've given you some constraints. You need to use my template. You cannot use your own, can't use your own assets, and so on. And that is really what I'm asking you to do for task number one. Really, task number one just moves things, all over the place and makes your game move and work. That's all it does. It doesn't. I'm not asking you to add new game elements or new mechanics or any of that stuff. Just make it so that the game is available so I can play it on landscape orientation with code, please. One other thing to notice before I move on is that the enemies and the player and the bullet, the fat bullet, they're all animated, right? So animation is going to be covered by Joss, starting off when you get back, not next week, which is reading week, but the week after. He's going to cover it, but really I've already implemented it for you. So if you notice, I've got several animations, one of them for the player, and you can see that the player uses something called an animation controller, which has a default animation state, which is the idle state. The idle state, what it does is if you take a look at sprites for the player sprite, I have 12 frames of animation for the player. They're all separate. They're not in a sprite sheet or anything else like that. And all I can do if I wanted to create a animation is I can just take all these sprites and drag and drop them into the scene, and then it automatically creates the clip as well as the animator. That's what it does. So that's how I made my player. Notice the player itself has a animator component that's attached to it. It's right here. And you can see that the animator uses the player animation controller, which is right here inside the animations folder. It uses the animation controller. And the player idle clip, it actually is, let's just look at the animation for a second. Here, I'll put it over here. The animation for the player, you can see that I have manually created these animations for the sprites, where you can see that the wings of the ship are going to move kind of out and back and out and back. And all I've done is I've used and it's hard to see this, but you can see that the wings actually get kind of closer and closer to the player body. And what happens is it just repeats this set of frames over and over again. Okay, that's what's happening with the animation clip itself. Okay, so that's what's happening for the player. It's also happening for the enemy, where the enemy moves its wings out and back. And for the ship actually, sorry, the bullet actually gets thinner and fatter. And I'm just done that manually by using some tools. Okay, I don't expect you guys to do that. I'm just showing you here how they can work. And literally, you just have an animator component that's attached to the player that can create this simple animation. Okay, and like you can see that the wings aren't exactly perfect. Who cares? Same thing with this, it just pulses out and back. And so it makes it look a little bit more interesting than a static object. Okay? And you can see how that player clip is playing over and over again, every frame. All right, so that is task one. So there's no animation component for task one. I'm just showing you that it exists, that it's attached to players. Okay, task two. Task two means, hey, deploy your game to an Android device simulator, either the virtual machine or an Android compatible smartphone. Either one. If you're using a smartphone, you need to be able to project your smartphone so that I can see your phone being used on your screen. You can use something like Visor, right? And if you actually look up online for Visor, let's take a look at that. I introduced that as an option for you guys. And what Visor does is it's a little app that's free that if you download allows you to kind of project your phone screen on your PC. Okay, that's what it does. So you can actually see your phone screen, how it's working. It's kind of a way for you to use your phone instead of a simulator. You're actually using the real thing. So if you're more comfortable using an actual Android phone, that's great. But if not, then you need to use a simulator like LD Player. And I've talked about LD Player from kind of early on in this semester. So there's LD Player. We've tested it before. Here's LD Player loading right now for us. and we've deployed our, we've kind of done our builds toward to LD player. What I'm asking you to do, one of the tasks for this exam, is to deploy to a virtual device like LD player or Genymotion or BlueStacks or something else that emulates an Android device or the actual device itself. If you want to kind of plug in your actual device and deploy to that. All right, so one of the two options. And that is what's part of this piece. This is worth 10 marks out of 100. 5 marks to actually switch platforms to Android. You should be able to do that. And the other part, 5 marks to build and run your project. Really what I'm doing here is I'm giving you 10 marks to deploy to an Android device or a simulator. Internal documentation, I kind of talked about this already, where I'm saying that, at the top of your code, when you're writing stuff, so for example, let's say in your player controller, put in your full name, student ID, date modified, file, description, and a short revision history of what you've changed, right? As an example, not anything else. Don't document my code, document your own code, all right? So that means that if you're changing something in the player controller, add a header, and then go to the area that you've changed. So I don't expect you to document what fire bullet is, but if you've changed fire bullet, so it fires in a different direction or something like that right through player controller, I don't think you should do it here, but let's suppose you decided to, then you would document your fire bullet method. So kind of // and you can start documenting what you did, okay? So that's what I've asked you to do for this one, right? So for your a header for all your classes and methods. You also need some kind of header, overall header for the file that you're using, and ensure your program uses contextual variable names. If you add variable names to your program, they have to be contextual, which means something that makes sense, not A's, B's, and C's, or some other random things, words that are cut short for some reason. You don't need to do that. Make sure that I can read the words. It should be human readable, all right? And also ensure you include inline comments. People ask what inline comments were. Remember, inline comments are something like this: delay bullet firing. This is what this little thing does. It shouldn't replace bad code. If your code is terrible and you don't know what's happening, you can't read the code and understand what's happening, and this little comment isn't going to save you, right? If it's some weird algorithm. But at least it's something, and that's what you need for internal documentation. There is no external document for this project, so you don't need to do that, but you need to share your files on GitHub, like I talked about before. To demonstrate best practices, you need to create a GitHub repository in the name of GAME2014 F2021 midterm dash and your student ID, whatever that is, okay? Replace the square brackets with your student ID. And you must have your code, and it must be well structured. So things like your project should be structured as we've kind of talked about in class. If it's some other weird structure we haven't talked about, as an example, you'll lose 2 marks, okay? And as well as your repository must include commits that demonstrate the project's being updated at different stages of development. If you just put it up once to GitHub, you lose 2 marks, for only using GitHub as a backup. Just letting you know. The other one is your short video, which we've talked about before. Please make sure you include an initial slide that's in your video, not a separate slide that's apart from your video. This should be in your video as a backdrop saying, "Hi, my name is Tom, and this is my midterm assignment. It's the space shooter assignment, and for GAME2014 in the fall 2021 semester. And here you go. Let me demonstrate this thing." And you're going to demonstrate everything inside of your simulator, or you can use your actual phone. You don't have to demonstrate just in your simulator. One thing to note is I will not accept your midterm test, this assignment, without a video. No video, no marks, like we talked about before. Okay, so that's kind of something. One more thing. You can see that there is a bonus area. So I've added a bonus area because some of you said, well, this is like super easy, right? I mean, my project is kind of like the one I'm doing for assignment of 1 part 2. It's kind of like what you're doing right now because that's one of the options that you've given us, Tom. Yep, you're right. But you need to use my template. You can't use your template. You can't use somebody else's template. I'm not asking you to download stuff from the internet. No downloading allowed. You have to use my assets. that I've given you. And one thing is, for a bonus mark though, I'm giving you a constraint, I'm giving you an opportunity to get extra marks if you make your project work in both landscape and portrait orientations. In other words, it adapts when it can detect an orientation change and work both in portrait and landscape orientations. So that's 5 points. I don't think it's that difficult to pull off. You just need to detect the orientation change. But the thing with the code is it has to be able to support both bullet shooting up, bullet shooting to the right. It has to support things like your enemies coming from the right side of the screen or the enemies coming from the top of the screen. When you move to the right, the player should rotate. Like, there's a lot of stuff that has to be done, but you've already got, if you think about this, half of it already done, because right now it does portrait, which means if you plan, you can make it so that it also does landscape. You add code as opposed to replace code, okay? The other one here is a little bit more difficult to do, using adaptive design principles, right? And scripting to enable your game to work on any device. That means any mobile device, not any, like someone asked, what about PC and console? No, I mean any mobile device, right? That's more challenging because you have to understand how to use the safe area as an example, so that you can detect where your game is in the safe area. How about working on a Google Pixel or some kind of Fold, like those kind of phones? How does it work? Does your game still work on those things? Do you shrink your game so it fits things properly? What do you do? There's a lot of work to do for those extra 5 points. So most of you probably won't do this piece, but you probably can do this piece there's quite a bit of work, but easier than doing this one. For the bonus, in order for you to be awarded the bonus, I will not award you the bonus unless you demonstrate it in your video. You talk about it. By the way, I did the bonus. Here it is. I can do both this and this. My game works in all orientations. My game works on any device. You know, those kind of things. So please demonstrate this. You can get up to 110% for this exam. And the reason for that is because you may have missed a lab. You maybe didn't do so great on your assignment 1, part 1 or part 2. This makes up some of those marks so that it's a little easier for you to do really well in the course, okay? And last point is right here, down in here. So this is your requirements, how you submit stuff. But here's some stuff that you need to know. For this midterm, external code is strictly forbidden, which means you cannot use any code from Stack Overflow or from a tutorial that you've watched, for example, outside of our course tutorial. So no brackeys, no other tutorial that's online, none of that stuff, right? You have to use, the only thing you're allowed to use is, you're allowed to use the Unity API documentation. That's fair game. Anything that I've shared with you is fair game. So if I've shared things like, for example, some code last week or the week before or whatever, anything that I've shared with you, use it. Anything that's on GitHub that I've given you, use it. You can't use anybody else's code in the class. It must be your own code or my code or Unity's code. That's it. So no Stack Overflow, no Reddit posts, none of that stuff, no YouTube. You don't need that anyway for all this stuff, okay? Here's the other thing. Unless noted above, assets and scripts must originate from the project template provided. In other words, unless you're doing something weird, right, you're going to modify scripts that I've already given you, all right? So, and no more new assets. So please don't sit there and say, you know what, I don't like the assets that you've given us. I don't like your bullets, and I don't like your thing. And you know what, I want to add my assets. If you use your own assets, guys, not only will you lose 5 marks, you won't be marked, period, the end. I won't mark you. And the other one is, and this is a hard one, but late submissions will not be accepted. That means you've got from Monday to Sunday. That's a full 7 days to get your midterm completed, unless there's a serious issue, an emergency, you have some kind of sickness or something happens and everything else that you need to let me know of. I need a doctor's note. You need to get this done within the time frame I've given you, okay? So those are all the things that I'm giving you. So a little bit of restrictions here for this one, but it's, again, it's open book. If you think about this, you can look at our slides for some things that you might need, or some concepts, if you will, but everything is something that you have in the template. Please use the template provided. Okay, I've talked nonstop now for for quite a bit of time, and I don't want to punish you by talking to you anymore. So like let's say 40 minutes already nonstop. Any questions about the midterm exam? Again, it was released yesterday and it's due on Sunday before we go. I think it's pretty straightforward. That's just me. I think I put a lot of details in there to tell you what I want you to do, but really there's not a lot of code changes for you to do. You can probably knock this off, just the basic version, probably within about an hour. Okay, 2 hours max. Okay, if you can't do it within 2 hours, you should question your knowledge. You should question your practice, the stuff that you know, because this is really simple stuff, guys. All right, it's not that difficult. So it's, or fairly straightforward stuff. Let's just put it that way. I mean, a couple of tricks that you have to work on, things like, your background, scrolling background, how that's going to work. That's kind of new. Touches, you don't really have to change, just change the direction of where you're going. For the most part, I think it's things you can handle. You guys are capable of this. All right, so if there's no questions, then let's go back to this. So remember, just for, just to revisit this again, we're sitting at week 7. By the end of the week, that's Sunday, your assignment 1 part 2 has been moved to the end of this week, so to Sunday of this week. And the second thing is your midterm test, which was released yesterday, which I've been talking about for this entire video, is due by the end of this week, Sunday as well. All right, so both those two things are due by the end of the week. So please make sure you get them done. And then next week, we won't be seeing each other. Next week is mid-semester break or intersession week. We'll be getting together not next week, but the week after for week 9. And in week 9, we're going to be talking about more advanced topics. And we're going to continue talking about design patterns and a bunch of other stuff coming up. And the second project, just as a preview of what's happening, assignment 2 is all going to be about platforming. And I was able to get a preview of some people's assignment 1 part 2 that they showed me in class earlier today. And I saw some really great ones. I saw one from Maxim. He did a great job in terms of his tower defense game. Really happy with what I saw. Herman showed me his stuff. Thanks, Herman. He's actually still here. Very interesting, unique kind of game that he showed me on that he made, as well as a bit from Chris as well. And there's other people that I'm sure, if you have a chance, we're going to stop recording now. But if you wanted to show me, the people that are physically here in class, if you want to show me a preview of what your game looks like for assignment 1 part 2, I will give you some feedback in order for you to get the maximum marks possible. Okay, that's it for me. Any questions again before we go? And I'm also looking at YouTube if there's any questions there. All right. Thank you so much, guys. I'm going to stop recording this now, and I'll take any kind of questions here in class. And if anyone's here that's ready to show me their project, I'd be happy to give you feedback.